Hello and welcome to a video on using the triangle sum theorem and the exterior angle theorem along with algebra. Now we're looking at the two theorems here, and remember that the three angles of a triangle on the inside add up to 180, and if you extend any side of the triangle you form an exterior angle, and that exterior angle is equal to the two farther interior angles, or the two non-adjacent angles inside the triangle. Okay, not the one that's right next to it. Of course, those are supplementary, but it's also equal to those two remote interior angles. We're going to set up a couple algebraic equations. We're going to do three examples here. So these are some things that we did in part one of this video set. And part two, we're going to go on to number 12. So we're looking at three angles, and they all have algebraic expressions. So we're going to use either one of those two theorems in this case to set up an equation. In this case, we can see we have expressions for the three interior angles, so those three angles add up to 180. So we're going to make one long equation. It's going to be longer than usual because that's the way triangles are. They have three parts instead of just two, but they all add up to 180. So I'll just start anywhere. It doesn't matter which angle I start at. I'll start at E because it's on the top. So I have 9x plus 3 plus 11x minus 21 plus 5x minus 2, and they all add up to what? 180. There's our equation. Now it starts long, but it's not that big of a deal because we can combine like terms and it's going to get short really fast. We have three terms that have x's, and we can add those x's together, and that's 25x. If you look at all the x terms, they add up to 25x. And if we add up all of the non-x terms, or all of the linear terms, I'm just going to underline them, the 3, the negative 21, and the negative 2. Well, we have to add the positives and the negatives, and I have 23 negatives and 3 positives. So that's 20 negatives. So that's minus, whoops, let's keep that in black, minus 20. And that equals 180. Add 20 to both sides. I want to use blue now because I'm doing something to both sides. And I get 25x equals 200. Divide both sides by 25. Divided by 25. And I get x equals 200 divided by 25. Last time I checked was 8. So x is 8. Okay, now we can find the three angles, now that we know x. So let's just do this. We have 5 times 8 minus 2. And now these should add up to 180, right, when we're done. 5 times 8 is 40, minus 2 is 38. So there's one of the angles. 11 times 8 minus 21, that's 88 minus 21. I'm going to use my calculator for that one. 88 minus 21 is 67. So this is 67. And then the last one, we've got 9 times 8 plus 3. 72 plus 3 is 75. Now I'm just going to check it because I always want to do this in geometry. I want to check my work if I have a way. And I know that these should add up to 180, so I'm just going to add them all together and just make sure. So I'm going to use my calculator, and I'm going to check. Here, let's just put this as a check. 75 plus 67 plus 38. And I'm just going to make sure that's 180. 75 plus 67 plus 38. And my calculator does confirm that it doesn't look like I made a mistake. I'm just going to write the answers in and move on to the next problem. So angle D is 38. Angle E is 75, and angle F is 67. These are all degrees. Okay, let's go on to the next one. Let's look at number 14. Now, 14, we don't have the option of using this first theorem. We have only one option here, and that is to use the fact that this is the extension of one of the sides, right? So that's an exterior angle that we're looking at. And that exterior angle is equal to the sum of the two remote interior angles. In other words, the sum of this one plus this one is equal to this one. Let's write that down in our equation. It's still long, but it's not quite as long as the last one. But I have 13, let's do this in black to start. 13x minus 11 plus 4x plus 1 equals that exterior angle, 18x minus 15. Okay, let's combine like terms. I have 17x minus 10 equals 18x minus 15. Oh, look, I got variables on both sides. Let me fix that. Let me subtract 17x from both sides. And let's just, at the same time, add 15 to both sides. And let's see what we get. On the left side, the 17x's cancel, and I just have a 5. On the right side, I have an x, and I'm done solving for x. Okay, x equals 5. Now I'm able to get all of the angles that I'm looking at here. I can get this one, so angle DCB, that's over here on the list. It might be the last one, it doesn't matter, I'm still going to find it first. So I have 18 times 5 minus 15. 18 times 5 is 90, minus 15 is 75. So that first angle is 75 degrees. Let's go on for the next angle. How about 4x plus 1? So how about 4 times 5 plus 1? That one's easy. It's 21. We don't need a calculator for that one. And that's angle ABC. So angle ABC is 21. These are degrees. Now the x is not degrees. The x is just a value, but the rest are angles. They're degrees. All right, let's go on and find this one over here. So we've got 13 times 5 minus 11. 13 times 5 is 65. 65 minus 11 is 54. So this is 54. And let's see, that's angle BAC, BAC or CAB. So that one is 54. And I've got one more, and there's no x there, so how am I going to find that? Well, I've really got two ways to find that. And by the way, a quick check, 54 plus 21 equals 75. So I'm doing things pretty well so far. They do add up. Check them. If you can't do it in your head, use your calculator. They do add up. Now we've got two ways to find this. It's the supplement of 75, or it's the three angles adding up to 180. Either way, it's going to be 180 minus 75. So this angle down here is 180 minus 75, or 105. I'll just put this right in there. Okay, so there's our angle ACB. That's the angle that we just found. That's the angle that we're looking for. There's our 105 degrees. Okay, so there is your typical example using algebra with interior angle theorem, the triangle sum theorem, sometimes called interior angle theorem, and using algebra with the exterior angle theorem. Okay, let's look at one more example of a different kind of problem. Everything on this page is pretty much the same as that. You're going to get some practice here, but I want to do one of these down here. So I'm going to do number 16. So let's look at number 16. This is one where you have to create an algebraic expression. So let's read it first. Okay, so you have a triangle, and the measure of angle K is 9 more than the measure of angle J, and the measure of angle L is 21 less than the measure of angle J, then twice the measure of angle J. All right, I think what I need to do is I need to draw this triangle. This triangle has the vertices JKL. I have no idea what any of these angles are, so I'm going to draw this as just your sort of typical first grade triangle. This is what you learn a triangle looks like, even though we know they have all kinds of different shapes. It looks kind of equilateral and equiangular, but we really don't know. So this will not be to scale when I get it, unless I just happen to have three angles that are all 90 or 60. They're all going to be different. But we have to start somewhere. So I'm going to call this J, K, L. It really doesn't matter which one I start with, just because I want to see something. Okay, and I want to be able to put something somewhere. And I'm actually going to say, I'm going to start to write some expressions now. Okay, so measure of angle K, this angle here, is 9 more than the measure of angle J. So if I call the measure of angle J X, then I can say that angle K is 9 more than x, or x plus 9. All right, now if only we related the other one to angle J or K, but let's see what we have here. Angle L is 21 less than twice angle J. Well, that's pretty convenient because I already named angle J x, right? So now I've got 21 less than twice x. So if this we had 9, if we called this one x, which we just got lucky and did that, then we've got x plus 9. And we did that for angle K. All right. Now we're going to look at angle L. So the only one that we need, angle L, is 21 less than twice. And this is my x still. I made it J, angle J in my x. So I just have to write that as an expression. So think about it. And it is 21 less than twice x. So 2x minus 21. That's what goes in there. All right, now I'm ready to write my equation. These three angles, which now have variable expressions, add up to 180. So I can say, it doesn't matter what order I start in. I'm just going to start with the one I just found. 2x minus 21 plus x plus 9 plus x. They all add up to 180. All right, so these, just to make sure that this is clear, this is angle L. That's the measure of angle L. This is the measure of angle K. And this, just that angle right there, is just measure of angle J. And those three angles add up to 180. Okay, now we're just on to algebra. So we've done the geometry part. We've loaded up that triangle with expressions. Now we just have to add them up. All right, so combining like terms, I've got 2, 3, 4x. So I'm going to start out there. 4x. My numbers are negative 21 and 9. Negative 21 plus 9 is negative 12. And that equals 180. I'm going to add 12 to both sides. And I get 4x equals 192. I'm going to divide both sides by 4. And 192 divided by 4. Again, I'm going to use my calculator for that. So 192 divided by 4 is 48. So there's x. Not only did I find x, but I actually found one of the angles already. This is 48. So measure of angle J is 48 degrees. Now I can find the others just by plugging in x. So this would be 48 plus 9, so that's 57. So the measure of angle K is 57 degrees. And then 48 times 2 minus 21, that's 96 minus 21. And sometimes I use a calculator even if I don't need one. I know you guys do that. But it's 75. We want to avoid that as much as possible. But that is 75 degrees. Quick check. Do the three angles that I found add up to 180? Well, let me see. 75 plus 57. So this is a check now. Do 75 plus 57 plus 48. Do they add up to 180? So 75, 57, and plus 48. And I'm just making sure. It looks like I didn't make any mistakes. So that's good news. That's like, yeah, I did everything right. Okay, hope you found this helpful.